All right, so I will never click that button again. You probably just finished watching part 2 of 6.1, which was a 7-minute video of me going through about 3 examples and then hitting the wrong button. So I really didn't want to erase the video and start over because that might make me cry because it takes a lot of work to make these. So anyways, I just kept the video. I thought maybe it would be kind of funny for you to watch. Funny little story. I know you guys can't see, but right after I clicked the wrong button, my power went out and I lost my internet connection. So everything just kind of happened at once. So that was great. But now the power is still off, but I have it on my personal hotspot. So hopefully this works. Anyways, you probably really don't care about my life. I just thought it was funny how everything just happened to crash at once. Not really that funny. I almost cried. So anyways, we were just simplifying some trig functions. Now, trig functions, we have that formula sheet again. So at the end of that video, I had just kind of finished this question right here, or just almost finished. So I was at the stage where it looked like this, 1 over cos x, which is what that numerator simplified to. And then it's divided by cosecant x, which is 1 over sine x. Okay, so when you're dividing, just invert and multiply. So you'll have 1 over cos x times sine x over 1. And then when you're multiplying, top times top, bottom times bottom, which is simply sine x over cos x. And then the question does ask us to simplify it in terms of trig ratios, like our primary trig ratios. So we don't want to leave it as sine over cos because we should know that sine over cos, which is right here, is actually what? Tan. So I can just write equals tan. So again, why I love these is because that gross looking thing over there just equals tan, which is so much simpler. And you could even just use that in your calculator. So yeah, it's awesome. This next question I will do for you because I just love doing this. You probably think I'm joking, but I'm honestly not. This is my favorite stuff ever. So got to write all of this stuff in terms of sine and cos. So tan x is sine over cos, right? You guys should know these a little bit. Sine over cos. And then cos is already just as it is. So if you want, you can put it over 1. You don't have to, but some people like that as a visual. And then over, now secant is 1 over what? Cos x. Lovely. And cotangent is what? Do you guys remember what cotangent is? Cotangent is cos over sine. So cos x over sine x. All right. Now we get to simplify, and this is like awesome because we're going to get lots of stuff that cancels. So in my numerator, you can see I can cross out those coses, and in my denominator, I can cross out those coses. So I actually have just sine x in my numerator, and in my denominator, I have 1 over sine x. Okay, so what that's saying is sine x, whoops. You can skip this part if you can just go straight to the inverting and multiplying part. That's great if you can do that. Okay, so I got that, and then that division is like inverting and multiplying. So that's like saying sine x times, I'm just going to use a dot so I don't get my x's confused, times sine x. Now sine x times sine x is actually sine squared x. Okay, and that's how you write that. There's 2 of them. Okay, so really not that bad. Honestly, as long as you can write it in terms of your sine and cos, you're going to be just fine. Okay? All right, we get to do this again. So it says simplify the expression to one of the reciprocal functions this time. Okay, so reciprocal functions meaning cosecant, secant, or tangent. Okay, so still Still right in terms of cosine sine though. All right, and then we'll just simplify from there and get a reciprocal function. Okay, so cosecant is 1 over cos. Okay, divided by tan, and tan is sine over cos. All right, so again, I like to write it laterally, so like this, divided by sine x over cos x. And that is like inverting and multiplying times cos x over sine x, which is lovely because those coses cancel and you get 1 over sine x. And what's 1 over sine x? Which reciprocal property is that? 1 over sine. It's right there. Cosecant. Woohoo! So equals cosecant x, which is one of our reciprocal functions. Yay! All right, perfect. So that's simplifying. That's looking at always dealing with terms of cos and sine and then getting an answer from there. Now, the last identity that we haven't went through yet are these ones right here, this bottom row. Okay, so there's 3 of them. They're called the Pythagorean identities, okay, because they have those squares in there. All right, that's why they're called Pythagorean. So what this question right here has us do is just rearrange them, okay, so that you know that you're allowed to do that. So it says change sine squared x plus cos squared x equals 1 to other identities. So if you look here, that's this first one right there. Okay, there's 2 others. Now you're able to manipulate these, and this is all I want to show you here, okay? So you could have that. You could also subtract cos squared x on both sides. And if you did that, you'd get sine squared x equals 1 minus cos squared x. And that's a thing, okay? You could also leave it how it was. And what else could I subtract? I could subtract the sine squared x, exactly. So minus sine squared x. All right, so then if I manipulated it that way, I'd get cos squared x equals 1 minus sine squared x. Okay, so that just shows you that you're able to manipulate all 3 of these, okay? Like I could do the exact same thing here. I could say tan squared x and then subtract 1 on both sides and say tan squared x equals secant squared x minus 1. Okay, you can do it the other way. As long as you keep your signs and everything, you're good, okay? So just know that you're able to manipulate those, all right? And that's all you have to look at there. Now, in this last slide, we actually use some of those Pythagorean identities, okay? So the first one says, simplify sine x over 1 minus cos squared x. Okay, so we can't simplify sine x anymore. We have to just leave that as it is. But this 1 minus cos squared x, so when I'm doing these questions, anytime I see a squared, I always think, okay, this has to be a Pythagorean identity. And it always is, okay? It's honestly, it always is, okay? So Pythagorean identity, which means I am looking at these last 3 rows, okay, or this one I'm going to start right now. And we need to see if they manipulated any of those 3, okay, any of these 3 to be 1 minus cos squared x. Now, I actually just did this. If I scroll up, what was 1 minus cos squared x? Do you see it? Right there. Right? 1 minus cos squared x. What's it equal to? It actually equals sine squared x, right? Because I had manipulated that identity. So I can actually write down here that 1 minus cos squared x is actually equal to sine squared x because of that identity. So what I actually have is sine x over sine squared x. Okay, and then that's going to be nice because it will simplify. Great. Lots of people hate that squared, so I always say don't worry about it, just write it twice, right? And that way it's really easy to see that you're able to cancel 1, but that other one has to stay in the denominator, so that you have 1 over sine x, which is cosecant x. Okay, so sometimes it takes a little while to find the Pythagorean identity that you're dealing with because you do have to manipulate them. But I will tell you, anytime you see that squared, always look there first. Okay? All right, I am going to stop talking. I am not going to do this last example. You will be fine without it, I promise. The last 2 videos ago, I guess, when I started chapter 6 or 6.1, I had you do number 1 and B. Okay, I want you to do page 296. So adding on to number 1A and B, I want you to do number 3, 4. Do 3 and 4. All. There's actually only A, B, C in there, so it's really not that bad. Okay, so 3 and 4 all. Do that. I realize that this kind of part 3, I guess, video, it is longer, but keep in mind, like I had said before, that this chapter is going to be very slow, okay? So probably to end the week, I'll get through 6.2 and then we'll be done. I don't even know if I'll give you a hand in, okay? I might take in a couple textbook questions, actually. All right, so that's that. Let me know if you have any questions. And again, I hope you enjoyed my comic relief in that last video. I definitely apologize. But yeah, my power is still out and it's lunchtime, so I'm gonna have to make sandwich. All right, hope you guys have a good day.